So welcome back to the second law of motion. So at this point, I want to review what we have done earlier. Okay, this is an object placed on a frictionless table. So they only have two different forces. First of all, there's force due to the gravity, and also there is a normal force. So every time when an object is placed or is put on top of the surface, just like for example, I'm just gonna go ahead and give you an example of the problem that would represent the same thing on the diagram. An object is placed on the table, so they have only two different forces. Also, for example, if I start pulling the desk on the table, my bad. If I start pulling the table, I'm applying the force to pull the friction. But what happened is that the table is not moving. So which means that there's some other forces acting upon the table that prevents the box from moving. And what it is friction. So I'm just gonna go ahead and draw that one right now. It's a friction force. And also I have an applied force. So basically, if that's the case, I have four different forces. So conclusion, and the frictional force must be much greater than applied force. That way the box is not moving at all. So we're gonna go ahead and apply the same concept here in this motion, in this diagram right here. I'm just gonna give you like if the box is not moving. So if the box is not moving at all, so what we can interpret that the frictional force is much greater than the force of apply, which in this case is the force due to the gravity, because the force of gravity is pulling the box down. So I'm just gonna go ahead and go right here, so we have more space. So I'm just gonna go ahead and draw the same one, but can I draw it this way? It's the same thing. It's an incline. It can be any angle. So I'm just gonna go ahead and draw the box. I'm doing two different scenarios right here. The box, this is the box not moving, so we know for sure that frictional force is greater than mg. But if the box is moving with the same acceleration, so we know for sure that Ft here is greater than the frictional force. So now I'm just going to go ahead and draw a free full body diagram. So, my bad. Let me go ahead and erase this thing right here. And let's make a consideration only with the box that is moving with the acceleration. So the first force is the force due to the gravity. We have an angle here, same thing. Draw these three different forces, do that one right here. So that one is forced side theta. So this one is Fg cosine theta. You will use the prior knowledge from the math right here to apply for this force. And also we need to know that there is a normal force, is that. So I'm just gonna go ahead and follow use first law of motions to determine the normal force. So the first law of motion says, can someone here explain or repeat or identify or describe the first law of motion to me again? Okay, an object that is not moving in the y directions, so it's going to be very specific y directions, right? So summation of the force, which is the force due to the normal force plus cosine. But it has been negative since it's the same magnitude of the forces but in the opposite directions. Therefore, that will become negative over here is equal to 0. So my conclusion is normal force is equal to, so normal force is equal to Fg cosine theta. So basically it will be mg cosine theta. And now we're gonna go ahead and use normal force to apply for the second law of motion. So we're gonna use second law now, which is the same thing, summation of the force is equal to ma, right? So now we're gonna go ahead and look at the x direction, x-axis. So the x-axis, which is the one is parallel to the incline. So that will be this one. And the question says we have a frictional force. So I'm gonna go ahead and add one more frictional force right there. So that would be F sine theta plus minus force of friction is equal to ma. And then I'm just going to go ahead and label other forces, F psi theta minus mu Fn is equal to Fg cosine theta is equal to ma. And from here, you are tasked to calculate for this one. So I'm gonna go ahead and ask that you try to solve it by yourself first, and then we double check about your calculator. Then we're gonna go over the calculation in class together.